Está subiendo ya. Está subiendo.
Ahí va a empezar.
Buenas noches a todos los que están aquí en esta la cuarta y última sesión de jConfColombia, serie online. Hoy nos acompaña, como siempre, Juan Carlos. Carlos, ¿cómo estás?
Hola Gilmer, buenas noches. Bienvenido a todos. Diego, ¿cómo estás?
Hola Juan, muy bien, gracias. ¿Cómo está el Gilmer? Saludos a la comunidad de Medellín, de Java y de Bogotá.
Okay. A todos los asistentes, como siempre, bienvenidos a esta sesión. Las reglas todos las conocen, a los que se encuentran en el Zoom pueden hacer sus preguntas en vivo. Las pueden hacer en inglés si quieren, las pueden hacer en español y algunos nosotros intentaremos traducirla. Mientras no van a hablar, por favor, bloquear el micrófono, ¿cierto? Para evitar de pronto sonidos que interrumpan la sesión. La sesión va a ser en inglés, porque es el idioma que el profesor Benca maneja, pero no se sientan tímidos de participar, ¿cierto? Van a ver código, van a ver cosas que, aunque el inglés no sea muy alto, el más bueno, es probable que entiendan bastante. Nuevamente agradecerles, ¿cierto?, a todos los que nos han apoyado durante este tiempo, a las tres comunidades, como decía Diego, o sea, Cali, Bogotá y Medellín. Nuevamente agradecerle a las empresas que nos han apoyado para esta sesión, que nos han acompañado también en otros eventos, nuevamente Ceiba y a CB, que nos han seguido apoyando para la realización de esta serie online, como hemos descrito. Esperamos que el próximo año, que los próximos años, una vez se normalicen las cosas, vamos a tener nuevamente sesiones presenciales en las comunidades locales y también pues, hacer una nueva jConfColombia presencial donde podamos participar e interactuar de manera directa. Entonces, sin más preámbulo, vamos a... No sé, Diego, si quieres decir algo de arrancar.
No, estoy muy contento porque este tipo de eventos se hagan. Quiero darle las gracias también a los patrocinadores y al doctor Venkat por estar atendiendo el llamado a la charla. Muchas gracias.
Sí. Entonces vamos ya a cambiar a inglés para darle la bienvenida a Venkat. Déjame yo descomparto mi pantalla. ¿Dónde quedó? Un momento, por favor, que perdí aquí el momento. Se me perdió el control del Zoom. Listo. Share. Ok. Ya. ¿Me confirma, Diego, si sigue compartiendo la pantalla o ya debería estar?
Sí, sigues compartiendo la pantalla.
Share. Listo, ya. Ya lo encontré. Aquí. Ok, vamos a cambiar a inglés para la bienvenida a Benka. Hi, Benka. How are you?
Hey, Elmer, it's great seeing you all. I really wish we could be there in person, but given the times, I think things are going well. Thanks for having me.
Remember, we have an appointment to clean the Bogota Monserrate mountain. And this is an appointment I hope in the soon future, me and another community friend can go there. But I'm not sure if I'm able to clean up and clean down because it's a big mountain, but maybe the good point of this mountain is there is a cable that you can go in the cable and you can down in, I don't know the English word, but it's something like a train that came from the mountain.
Yeah.
So that will be a good option to go there.
I can't wait.
I'm happy you accept this invitation, and this is the second time you are with us and now online. And please, when you want to start, you can start.
Very good. Awesome. Well, again, thanks so much for having me. I really appreciate it. I want to thank everyone who has joined here online and also through YouTube. Best time to ask questions or make comments is anytime you have a question or a comment. So please don't hesitate to ask questions or comments. You can put them on the chat anytime. I'll respond right away. Or if you want to just turn on your microphone and speak, that's perfectly fine as well. So let's get started. Well, I want to talk about refactoring your language knowledge portfolio. And I'm going to say we are what we code in. And I want to talk a little bit about languages and evolution and what are some of the things we can do to facilitate adoption of not only languages, but adoption of languages we use as well. So I want to talk a little bit about some of those things along the way. So I'm going to spend about maybe an hour or so talking about these things, and then hopefully we can have a bit of a Q&A and discussions after that as well. But like I said, don't hesitate to ask questions. Anytime along the way is a good time. So let's get started. Well, I program in about 15 different languages. And what I'm saying in those many words is I'm not good in any one of them, but I really, really like programming languages. And part of the reason I like programming languages is that it really gives a way for us to broaden our thinking, broaden our way we design software. So languages are a lot more than simply the syntax. In fact, I would even say that syntax is probably the least interesting thing when it comes to a programming language. But let me just reflect back a little bit on my own journey. When I started programming, I've been programming for, I'm going to say maybe about 35 years or so. And when I started programming for the math and science and engineering in it. But about 35 years later, I still write code. And the reason for that is a little bit different from what I started out with. So when I started programming, the science and engineering in programming drew me in. But it's actually the art in programming that has really kept me. And that's one of the things I really want to emphasize is when I look at programming languages, in one part, I see the science and engineering in it. But for a significant part, I look at the art in programming as well. If you really think about language, so what's a language? A language is a way we communicate. In a case of a natural language, we use natural languages to communicate between human beings. You may speak in English or Spanish or Portuguese or French or, whatever language you choose to speak in. Those languages are used to communicate with other human beings. In a similar way, a programming language is used to communicate as well. In this case, to communicate with the computer, but also to a fellow human being as well. But it turns out, if I were to go to somebody and say, write a poem about maybe love, or write a poem about nature or weather, whatever it could be. Well, no two people may write the same poem, even though the poems may communicate the same concept or idea or sentiment or feeling or emotion. We could potentially write infinite number of those poems for a particular idea or a concept. And similarly, for the same execution, we could pretty much create infinite number of programs. And to me, honestly, that's what excited me about programming, is that we can express the idea in one way and we can come back and refactor it to really produce the same output for the same input, but be able to produce that code in a very different way. And that's where the art form really comes in. I would say luxury, probably. One of the luxury that I have for myself is I can write the code and I can come back and spend the time refactoring it, maybe sometimes even a lot longer than what others may be able to afford it. And the reason is that I really enjoy not only writing code, but more important, to rewrite the code that's been written already, especially by myself. So, and that's where, again, the art form really kicks in very effectively when we start writing these code. And as Kurt Vonnegut said, I want to stay as close to the edge as I can without going over. And he says, out on the edge, you can see all kinds of things you cannot see from the center. I love climbing up the hills and the mountains. I hike up the mountains quite often. And of course, I'm really scared of heights, but still, nevertheless, I want to really walk near the edge and take a look at what's over there. And that's a lot more fun than just staying away way in the middle. And when it comes to programming languages in a similar way, I always want to push that boundary. I want to learn languages that I'm not familiar with. I want to explore details and design patterns that I'm not familiar with. And when we take ourselves out of the comfort zone, it's pretty frustrating when we do this, but it also gives us the opportunity to explore new ideas and different ideas. And as like Kurt Vonnegut says, it's always great to be on the edge and looking out, and that's a lot more fun. And I want to be able to do that as much as I can. Now, of course, programming is a fairly nascent field. If you look at medicine, if you look at building construction, if you look at poems and art and various other fields of human endeavors, they've been around there for centuries on end. Programming has been around for, a good 50 to 60 years, if you will. So it's a very nascent field compared to a lot of other human activity. But it's a very important field nevertheless, and it's something that's gaining a lot of importance, especially in the today's world where we live in today. Is programs are very significant part of the commerce that we live in. We cannot imagine the current society without computers. So what was a rather esoteric field only a few decades ago is a very central part of what we do today. But let's talk about this a little bit further. Let's think about this for a minute. Let's say I want to buy a car. What kind of car would you recommend that I buy today? This is 2021, isn't it? So I'm going to go out and say, hey, I want to buy a car. What would you recommend that I buy as a car? Well, you probably will tell me, oh, Venkat, you should really buy an electric car. Hey, that's a great advice. I could go buy an electric car, whatever car I want to buy, which is electric. And a lot of car manufacturers today provide electric cars. And so I buy electric car, and so does everybody else that you know of buys electric cars. What would happen if a lot of us start buying electric car as it's already happening? You may say, well, if a lot of people buy electric cars, then what's going to happen is that we are not going to fill gasoline into cars anymore. We need to start charging electricity into those cars. Then what's going to happen? Well, you may say the whole of the United States, you could say the whole of the United States will be sprinkled with electric charge stations, isn't it? Because you would need the charge stations everywhere. Well, that's actually a quote, and somebody wrote about it. That's a quote that said the whole of the United States will be sparkled with electric charge station, change station, and that was a quote from 1899. You say, wait, did I print it wrong? You are thinking. No, it's actually a correct quote from 1899, a good 122 years ago. And you look at this and say, really? Did they talk about what's going to happen in 2021, 121 years ago? Oh, no. It turns out that most of the cars 120 years ago were actually electric cars. So it turns out 1/3 of automobiles on the road in the 1900s were actually electric power car. I did not know this. I was blown away when I found this out. And we all think that the cars were always gasoline driven, fossil fuel driven. As it turns out that 1/3 of the automobiles in the world back in 1900 were electric powered cars. Now, as it went on, about 1920 timeframe, Ford really found a way to more effectively manufacture gasoline powered car, and they became a lot more reliable, and eventually electric cars faded away. And a good almost 100 years later, suddenly a new generation of people are excited about electric vehicles. And now we think that's a newfangled thing, but it turns out electric cars were the old thing to begin with, and we are still getting really excited. Now, why is Venkat suddenly talking about electric cars, you may wonder? As it turns out that in the beginning of the car manufacturing back in 1880, there were steam-powered cars, then came electric-powered cars, then came gasoline-powered cars, and now we are excited about electric power cars one more time. And there's a similarity between this and our own field, isn't it? Our field has gone through a very similar evolution as well. As it turned out, back in the 1950s, the most popular programming paradigm was actually functional programming. And then, of course, a little bit about structured programming. Then came along object-oriented programming, and OOP was actually introduced in 1967, and which is kind of shocking if you think about it. Functional programming was popular even before object-oriented programming even existed. And then, of course, if you grew up programming in the 90s and 2000s, you think OOP was the standard way of doing things. But as it turns out, we are yet again interested in functional programming. So what was originally the way of doing things is really what we are excited about right now, much like how electric cars were popular and now they are popular again. We can see that functional programming was popular once upon a time, and it is gaining popularity once again, as you can see. So what an interesting similarity between what happened in the automobile industry and in the programming world. We are yet again excited about something that's been around for quite a long time. But in the case of programming, what is really exciting about this is that functional programming has been very nicely tried and tested. So this is not a newfangled idea. It's been around for a long time, very well established. And that's one of the nice things we have with functional programming. But let's talk about programming paradigms, but more so about languages itself. Let's focus on Java along the way, but we'll mix in a few other languages too. If you really look at where this all started, can you even imagine? It has been 26 years since Java was created. 26 years. What is 26 years? That's about 2 generations of programmers, if you think about it, right? So about every 5 to 10 years, we got a new generation of programmers coming into the industry. And you can see that there are grandfathers who programmed in Java all the way to grandchildren who are programming in Java. It's just absolutely fascinating. But if you look back in time, we have the Java virtual machine providing a very strong fundamental ecosystem. On top of that is a very powerful and versatile JDK, and then comes along the language Java on top of it. But of course, we were told Java is simple, but we all know it's actually simpler than C++, because the word simple is very relative after all, isn't it? But if you really think about how it evolved over the time, the JVM is the most ubiquitous part in the whole thing. That's where the real power really is on the JVM. The JDK, of course, is very widely used, not only within Java, but across multiple languages on the JVM. But the Java language itself, what can we say? Well, I'm happy to note that it is evolving today much more than it did in the past. And that's really the power of Java, is that it constantly keeps evolving. But in terms of the emergence of languages, if you really think about it, back in the 2000, there was an exodus, you may even say that way. People are moving on to Ruby and Rails. Of course, that's tapered down right now, and not many people are excited about that anymore, but there was a significant migration into Ruby on Rails. But here's the problem though. What did it mean to program in Ruby and Rails compared to programming in Java? Well, that's like turning in your passport, selling your home, giving away your property, and emigrating to a faraway land. That was expensive and hard thing to do. That's basically what you had to do. You had to give up everything you did with the hope of doing better in this other environment. Then, of course, around the 2003 timeframe, we had a renaissance of languages. And we, of course, had languages like Groovy and Scala and JRuby and Clojure. And those languages started developing after the year 2003. And you can see that again was almost 20 years ago, give or take, if you think about it. So it's pretty interesting how the journey started moving. But the sweet spot of languages like Groovy and Scala is you don't have to sell your property. You don't have to give away everything you have and emigrate to this foreign land. You could be on the JVM, but you could use a different language. That's a power we got from some of those languages. But the question, of course, is what does it provide for us? Well, we can use the ubiquitous JVM. We can use the widely used JDK and the power it provides, but we can pick and choose the languages that we want to use on the JVM, whether you use Java or Scala or Groovy or JRuby or Clojure or Kotlin or one of the other languages that's available there. You get to choose what you want to use along the way. So all of a sudden, what was old is new again. And Java itself has this new birth in terms of what we can do with Java. You know, if you told me back in 2000 that I can write Lambda expressions in Java, I would have really laughed and said, really, are you kidding me? But look at the power we have in Java today in terms of what we can do with it. But of course, it's not about the syntax. And syntax is important, no doubt about it. But it's a lot more than syntax that we really need to focus on. And we need to really think about how we can structure and make use of these things across languages. So it's not about the syntax, but then what is it? Well, when it comes to perception, we as human beings have to always deal with this perception. And life can be really hard sometimes, depending on the perception we have. Here is a favorite picture I've seen before from Stephen Covey's 7 Habits of Highly Effective People. Now, if you look at this particular picture, if you will, what do you see? Do you see an elderly lady, maybe an 80-year-old lady, or do you see a very young lady, maybe 20s, if you will? Well, or do you see both? For example, you might have seen a beautiful eyes right there. What a beautiful facial feature you see of a very young lady right there. Or maybe you saw these very old but wise eyes and a big nose that's there for the elderly lady. So you may have seen a younger lady here, or you may have seen an older lady here, but that's just a perception. But that's exactly what it is. When we work with a certain perception, it becomes hard to see the other one until we are willing to really compromise, let go of one perception and look at another. When it comes to programming languages, it is just the same. It's a perception. Not only looking at other programming languages, but also looking at the same language as it evolves. For example, I cannot tell you how many Java programmers get very angry when they look at var and see that they can use type inference. Well, that's a perception. And if you're not willing to give the benefit of that perception, we cannot really keep up with the change in the language. And we are resistant about the change because we are not willing to look at that in a different perception. That becomes extremely critical for us to be able to benefit. So a perception is something we need to really keep in our mind continuously along the way. That is something we need to really focus upon every single time about perceptions and see how we can deal with them. Now, of course, when it comes to programming languages, it's not about the syntax, but it's about the idioms. So what are really idioms? Idioms are really hard in general. For example, if you think about natural languages, right? Take an example of English. There are people speaking English around the world, if you will. There are people speaking English in England, the UK, in Australia, in the US, but in India and several other parts of the world as well. But even though they're all speaking English, The vocabulary is a little bit different, but it's the idioms that make it really, really hard. So what are really idioms? Idioms are structured by some stories. Idioms are structured based on some connotation or events that may have happened in the past. So idioms are what is really native to the people of that region. For example, in English, you probably have heard a few different idioms. For example, people say it is raining cats and dogs. Well, of course, we know cats and dogs don't fall from the sky, but that's an idiomatic statement to say that it's raining cats and dogs, meaning it's raining really, really heavily. Or you would have heard a statement saying it's a slam dunk. Well, you cannot look at the word slam and the word dunk in a dictionary and know what a slam dunk means. But again, it's a connotation. In a similar way, when it comes to programming languages, there are idioms as well. And what would people programming in that language predominantly use and the way they will program? You know, I'm very humbled about this, and I'm very thankful as well for a privilege that I've written a few books on programming languages, but anytime I write a book on a programming language, I often have the author of that language review my book. And I'm really humbled because those authors will write an email to me and say, hey, Venkat, I'm looking at this example on page 127. I don't think you want to write the code like that. It runs, it compiles, it works, but here's the way you really want to write it. That is an idiomatic improvement that the author of the language is suggesting that I actually modify the code. And that is something we constantly do, is to find ways to improve and program in an idiomatic manner. So when it comes to programming languages, it's not the syntax alone we should be interested in. We should ask the question, what's an idiomatic way of writing the code in that language? That is one of the things we need to do. And those idioms can change and evolve over time. For example, the way I want to write Java code in 2021 is different from the way I would have written Java code in 2002, for example. So as time goes on, we have to really keep up with this evolving idiomatic styles as well. And that is a responsibility for us as professional programmers to keep up with those changes. But here comes the interesting part about languages like Java or Kotlin or Scala or Groovy or Ruby or Python. You say, whoa, there's a lot of languages you mentioned over there. But there's one thing common between all those languages, C# and Java and Kotlin, Groovy, Python, Ruby, Scala. What's common between all of those? Those languages provide a hybrid paradigm. You can do imperative style and object-oriented style of programming. You can also do a functional style of programming. So you get the power of two different paradigms or three different paradigms that work together. Kotlin itself is a multi-paradigm language. You can write scripts using it. You can write code using functional style. You can write object-oriented code. You can write imperative style code. It's a language that gives you the flexibility to choose the style that makes sense for you. Similarly, in Java or Python or Ruby or Groovy or Scala or C#, you get to decide the paradigm that makes sense. So rather than an on-off switch, you get to really dial in and use a little bit more imperative or a little bit more functional, and you can tailor this based on what you really want. And that's the power of these languages, is those languages don't tell you, here is one way to do. Most languages today are those hybrid languages that we can benefit from. So in that regard, I want to channel in words of Stuart Halloway. And Stuart Halloway is one of the committers behind the Clojure language these days. And Stuart talked about essence versus ceremony. I highly encourage you to Google for essence versus ceremony, Stuart Halloway. and you will see his blog post, beautiful blog post. I encourage you to take a look at it and read it. He says, good code is the opposite of legacy code. It captures and communicates the essence while omitting the ceremony or the irrelevant details. Irrelevant details. Capturing and communicating essence is hard. Most of the code I have ever read fails to have this, and he goes on to say more. Look at the focus on irrelevant details. Let's think about this for a minute. Suppose you are told to teach somebody, maybe a friend, and they want to learn to program, and you tell them, I can teach you Java. And they're like, really? Is Java hard? Oh, no, it's a simple language. And then they say, gosh, that's great. Teach me how to write hello world. What do you say? You say, sure, sit down. Let me teach you, you say. Then you say public. And they say, excuse me, but what is public? And you tell them, you don't need to know that right now. So your student takes the notes, public, no need to know that right now. Then you said class, and they say, excuse me, but what's a class? You don't need to know that right now. Okay, class, no need to know that right now. Then you said, hello world, and there's a glimmer of hope in their eyes. And then you said a curly brace, and they're like, I don't know what that symbol means. Then you said public, and they say, oh, I saw in the notes, I don't need to know that right now. Then you say static, and then verily they say, excuse me, is static also something I don't need to know right now? And then you take a deep breath and say, yes. And then, of course, they look at this unfold into main, a void main, a string, a square bracket, args, and they're thinking, oh my goodness, what I got into. That is ceremony. Now you may say, oh, come on, Venkat, but the JVM needs a main. That is totally correct, but that's JVM's problem, not the programmer's problem. So in the case of Java, we forced ourselves to write all of that and say hello world, and for us to execute it, that's a ceremony we saw. On the other hand, I can simply say print line right there. And how about saying hello world right there and simply execute that code? That's Kotlin code producing the hello world as an output right there. But you say, wait a minute, but didn't we have to go through all that ceremony that we have to go through in the case of, Java? Well, the answer to that question is, I can say Kotlin C -JVM, and I'm going to compile the bytecode, the Kotlin code into a bytecode, a Java bytecode. If I take a look at this right now, notice the sample.class sitting right there. I say Java P -C -V, all those options I've aliased on my machine, and I'm going to take a look at the sample.class and notice what happened right there. You can see Java Kotlin compiler created the main for you. It created a public static final void main and wrote the code for you. And the Kotlin compiler says, hey, the fact that you need the class is not your problem, my programmer. It's a problem of the JVM needing that, and we will take care of providing that for you. And what is that? Essence versus ceremony. So it's not forcing you to do things you don't want to do, but languages can help you quite a bit along the way. Now, don't get me wrong. I'm not trying to suggest that Java is bad and Kotlin is better, but it's important for languages to think of the programmers. It's important for languages to work on the part of the programmer to remove the ceremony. In that regard, here is a Java code I just wrote. And yes, it's a bit ceremonious. That's a nature. And maybe eventually that'll go away. But how do I run this code, if you will? Well, what are we used to? Java C -D temp classes sample.java. We compile the Java code into a bytecode. Then you say Java -class path, and then I say temp classes. And then, of course, in this case, I'm going to run the sample class and I may run it like that. But then you say, my gosh, that's a lot of work, isn't it? Why should I do so much? Why can't I just say Java sample.java much like how I will simply say Kotlin, C dash script and run the code right there. Let's say Kotlin C JVM script sample.kts. Notice I didn't waste my time and effort compiling the code and then executing. Why shouldn't I be able to do exactly that? And the answer is you should be able to. And notice I was able to now, thanks to a newer feature in Java, I can run single file Java code in a very similar way like I did here for Kotlin. So we took a Kotlin script right there and we simply said Kotlin C-JVM, and I simply said, here comes the script, and ran the code as it is. And that's exactly what I did. And a similar way, I can simply go over to the Java code and say Java sample.java, and I can execute it. I can use the shebang if I really wanted to and run that like a script. And as long as it's a single file with the classes it needs, I can also add a class path. And so what does the Java command do? The Java command recognizes that I have a Java source file being given, not a class file or the class path, and not the name of the class. And as a result, the Java runtime fires off the Java compiler behind the scene. And then, of course, it asks it to execute that compiled code from the memory. So less ceremony, a better life for me as a programmer. So languages move towards more essence and less ceremony. One great example of that is Java itself. Java is evolving towards low ceremony and high essence. And that is one thing we can celebrate as programmers as we work with the language. So that ceremony is something we want to remove as much as we can. And we can see that ceremony coming down, but it can go on further to remove that ceremony in so many different ways. For example, if I were to go back to sample.java, and in this case, if I were to simply say thread dot, let's say sleep, and I say 1000, as you know, that code will not compile. What's the problem? You are getting an error that you're not handling a checked exception. It says either put a throws or put a try and catch block. And I'm sure every one of us have done this. You put a try and then you put a catch right there. And then you ask the question, hey, I put a try and a catch, but what do I do with this exception? And then we spend the sleepless night thinking about how to handle that exception. That's a ceremony. So this is quite debatable, right? You can ask the question, is a checked exception good news or a bad news? It turns out the only language on the JVM that actually has checked exception is Java. Every other language simply says we don't care and treats all exceptions as if they are unchecked exception. So if you're programming in a language like Kotlin, you could simply say hello, but you can also say, for example, a thread.sleep, if you will, and you can specify 1000, but you don't have to go through a try and catch around it. You can see the code executes just fine and produces the output after a delay, but that's basically the language saying you don't have to catch an exception, but better be careful what happens if that exception were thrown. If you don't handle it properly, your program will blow up. So face the consequence of that. So languages can work towards removing the ceremony, removing the burden as much as we can, so it becomes a pleasant experience for us, the programmers. Let's take evidence of this in a few more situations. Let's think about the old Java and the new Java as well. So I want to read this file. So how do I read the content of this file? So I'm going to say java.io.star, and I could say a buffered reader. Reader is equal to new buffered reader, new file reader, and I'm going to specify a sample.java like so right there. Now, obviously, I'm going to get an error that I better handle the exception. It says file not found exception must be caught or must be thrown. I'm going to simply say throws exception, so I don't have to deal with each one of them separately in this particular example. Now that I have a file, a buffered stream, what's the next thing I want to do? We all have written that really scary code, isn't it? So we say string the content, let's say, is equal to empty. And then we could say potentially a string text is equal to null. Then we say while we could say text is equal to reader.read line, and we could say is read line, and then take that content that we get back, and then we say is not equal to null. Then what do? We say content plus equal to maybe the text we obtained, and in the very end, we could output the content that we have obtained and display the content, if you will. So if you notice there, that's one scary piece of code that we wrote, and along the way, it also lost the carriage returns and so on. That's a lot of effort to read from a file. And then you wonder, why do programmers prefer languages like Python or other languages? Well, that's because the verbosity involved can be really excruciating. Now, we'll come back and talk about how Java is different today, but let's take a look at an example in the case of Kotlin, if you will. So what can we do in the case of Kotlin? Well, I can say print line to begin with right there. And within this, I can say right here, java.io.file. What an irony, we are using the Java JDK file. And I say sample.kts. Then I say over here let's say in this case, I want to say .read text, and I want to read the text out of that file and display its content. When you look at the output of this code, notice the lack of ceremony. It was able to read the file's content as it is and pull the data out. If you're really curious about it, you could also try to say, for example, in here, something along the lines of, let's say, work area, let's say java/sample.java, and I ask it to read the Java file for me rather than my Kotlin source code, and we can try to read that content. And maybe because I gave a tilde right here, let me try to provide the proper path over here. Let's give it a /user/Venkat/work area and ask it to read the entire path given to it and ask it to read the content. And you can see how trivial it was to read the content of that file. You say, gosh, that's really simple. Why can't I do something like that in Java? And the answer is, well, actually, you can. That's one of the other reasons why we want to continue to keep up with the language development, because we are missing out on such a great amount of things we can do if we don't keep up with the language. So in order to understand this, let's compare the code we wrote up there to what we could potentially do. So I have a java.nio.star. Now notice what I can do here. Simply output that one-liner of code that you saw in here. Why can't you do something like that, you say? Well, let's do files dot and read a string. And what are we interested in reading? Paths.get, and the file is sample.java, and I want to read the content of that file in one shot and bring it over right here like so. So as a result, in this case, I say a file dot, not files dot. So file dot read string and paths, and I'm able to access the content of the file. And what is the paths? The paths and the file are coming from the Java dot, it's files rather, dot file dot, pardon me. And I want to say files, but that's coming from the file itself. Let me go ahead and provide the input right here. So there you go. So that's saying I want to read the content of the file in one line of code, if you will. And you can see how we said output files.read string, and read string is such a wonderful function that can read the entire content of the file and give it to me as a string. If you say, great, but I really want to process this as a stream API, go for it. So files dot lines, and then of course you can specify paths dot get, and that's going to be the sample dot Java that I'm interested in reading. But then what I'm going to do is to say dot, let's say map, and string the to uppercase, if you will. And then finally I can say for each and simply provide over here maybe a system dot out and print line, and I can simply print the content of that file in one shot. So that again becomes a very easy way to process and all these capabilities. And this is one of my most recent favorite, is where I can just read the string directly. Again, we can see the lack of ceremony, power of the API, less verbosity that often makes things harder for us. All those things are gone. And as a result, our life becomes a lot easier as programmers. So that's an example of reading a file. Then I want to think about something a little different. And I've been thinking about this more and more in recent times. I want you to think of the word statement, and I want you to think of the word expression. Just say it aloud. Statement. Notice how grim it is. It's like a life was taken out. Expression. Don't you feel light when you say the word expression? Don't you feel new energy in you when you say the word expression? I love expressions. So what are really expressions? Well, the difference is statements, unfortunately, do work, but do not return anything. So as a result, they force side effects and mutation. Expression, on the other hand, do computation, if you will, computation, and return from the call results. They do not force side effects, or mutation. So in general, expressions can honor immutability, but statements can't. So it called me silly, but it took me a while to really realize it. So one day it dawned on me, and I said to myself, oh my goodness, functional programming languages then can't have statements, right? So that's one of the aha moment in my mind. I said, oh my gosh, functional programming languages honor immutability, which means they cannot have statements. And that to me was mind-blowing. And I then started looking into it more and more. Languages like, Haskell, Scala, Kotlin, those languages, Scala and Kotlin, have derived a lot of strength from languages like Haskell. Well, in that case, the symptoms of that should be there in those languages, isn't it? And that brought me to think about statements versus expressions. And it turns out that as we design our own API, if we can program more with expressions and fewer with statements, that's going to make a code a lot easier to work with, easier to maintain the code that's written as well. But the question is, what can be an expression? Well, that's the funny part. The languages like Ruby provide expressions almost everywhere you think of. For example, let's define a Ruby code. I say, can I vote? And I'm going to take an age and send the age to that function. Now, in this case, I'm going to say result is equal to if, and I can say age. In this case, I can say if the age is greater than 17, then I could say, please vote. And else I could say, for example, go home kid. And then finally, I could say end. And I can then say over here, something along the lines of puts, can I vote? And I can ask the question, and I can display, in this case, maybe the result of that particular call. and I can display the result of it like so. So if I were to call can I vote and send a 12 versus maybe a 19, what is going to be the result? Notice it says go home kid for the first one and please vote for the second one. But the beauty of this is that is not an if statement, but it's an if expression. Now think about that for a minute. It's an if expression, not an if statement. So if languages can provide expressions, but what can be an expression? And the answer to that question is it's whatever you want to be. For example, class, my class, end. And I'm going to go ahead and say, here is a class I've created. But you say it's a class, right? But in Java, you define a class as well. But why can't a class be an expression? You say, wait a minute, what does it mean for a class to be an expression? Well, back here in Ruby, I could say, for example, right here, why not say store equal to? And I'm going to say put store, and I'm displaying the content of that. And you may wonder, what in the world does it return? What if I say hello within the class like so? Notice it printed hello. So as a result, in the case of Ruby, a class is an expression, and it can return whatever the class is going to return back to you. So a language where most of the stuff are expressions rather than being statements. In a similar way, if you look at Kotlin for a minute, in the case of Kotlin, I can do print line, let's say hello. So when I run this code, it printed hello. But then you say expressions, right? So what if I were to go back to this code and said print line, hello? Now, in the case of Java, you obviously cannot do that. Why? Because println or system.out.println is a void function. What is void? It doesn't return anything. In the case of Kotlin, though, I can run that code and you can see hello being printed, but it also says Kotlin.unit. What in the world is unit? Unit is a return type of a function that doesn't have anything else to return, a crude equivalent of void. But the point is, every function returns something. In other words, functions are expressions and not statements in the case of Kotlin. In the case of Java, there are expression functions and statement functions. Kotlin doesn't have the distinction. Everything is an expression as far as functions are concerned. So that's another distinctive nature we understand when we program in languages. How does it help? Once I get the understanding of that, I think very differently. These days, when I program in languages like Java, I design more expressions and not as many functions. This influences the way you design your API, you design your functions, because you think of expressions, and that can be a beneficial. It avoids side effect, it avoids mutability, it also gives nice functional chaining. Statements don't compose. That's another problem with statements, is that statements don't compose, right? So as a result, what's going to happen in this case? So as it turns out, statements, if you will, do not compose well. So you cannot take a statement and call a statement after that. These are treated independent of each other. Functions, expressions can flow nicely. The output of a function can become an input of the next function, and you can flow through them as well. That becomes a very powerful way of writing the code, as you can see. So each language makes a difference, and languages greatly influence each other. I never like to use some words, like somebody the other day said, this language is stealing from another language. Oh my goodness, what a silly thought. Why would languages steal from each other? That's not stealing. The languages are there for us programmers to benefit. So if you're programming in a language, you want that language to evolve based on the learning from other languages. And Kotlin grew out of many, many, many languages. In Kotlin, I see C#, I see Python, Haskell, Erlang, Groovy, Ruby, Java, and so many other languages, including C# and JavaScript. And Kotlin will not be the language it is if the developers, the designers did not learn from all those languages that are there. Similarly, Java is evolving. The developers behind the Java language are learning from a lot of languages, but implementing in their own way to make it really useful for the JVM and for the Java programmers on the ecosystem. So languages constantly have to evolve, but languages leave a mark. So languages make a significant difference in terms of what they provide and how we are able to benefit from them. So in that regard, if you think back at languages, you probably recognize who this person is. It's Bjørn Stroustrup, and Bjørn Stroustrup is the author of one of the most famous languages in the world, C++. Now, I'll admit to you, I spent my youth programming in C++. That's what I did as a young fellow programmer. I wrote code in C++. Those were dangerous times. I lived wildly, as you can imagine. Well, C++ itself is one such language. It's amazingly fast, but incredibly dangerous. It's a language, in fact, Bjørn Stroustrup said, C++ is a language that you can use to program or shoot yourselves in the foot. And that's his words. And he said, it's a language that gives you the power to shoot yourselves in the foot. So it's a very powerful language, but it's also a language which has a lot of flaws in it from the point of view of tripping the programmers. A lot of surprises for programmers who are not careful. It's a language with high cognitive load, and that's one of the problems with the language. On the other hand, when Java was introduced by James Gosselin, Java, he intentionally removed a lot of stuff in the language that were confusing to programmers in C++. So Java was intended to be a lot more simpler C++. Of course, added on top of it was the automatic garbage collection. Java itself has its own flaws, but it was such an improvement compared to C++. And I remember as a young programmer who is very used to C++, learning about Java and saying, wow, that's amazing how a lot of these things are simplified in the language. So that's basically the mark that Java left on the world, is bringing the automated garbage collection to the forefront. Java is not the first language to have automatic garbage collection, but it made it very prevalent. It's a language that removed a lot of ceremony. It's a language that also brought this idea of write once, run anywhere. So a lot of these mark. So what did C++ do? I have the deepest respect for C++ because whether you like it or not, C++ made object-oriented programming mainstream. Before that time, OOP was talked about, but not well practiced. C++ made it a common paradigm, and that's a credit to it. It was not a perfect language by any means or imagination, but C++ put its stamp on the world and said, my contribution was, C++ says, that I brought OOP to the mainstream. Java, on the other hand, put a mark on several things: a standard way of writing code across operating system and platform, the ability to do automated garbage collection, a simplified notion to remove the burden, the cognitive load. Those were the marks of the language. But when I look at languages, I look at languages very differently than maybe somebody else does. And I consider some languages as bridge languages. So what are really bridge languages? Bridge languages are not destination languages. They are for some, but not for others. But bridge languages are languages that move people from one end to another, from one paradigm to another. So C++ to me is a bridge language. It took a vast number of programmers from structured programming to object-oriented programming. Otherwise, they wouldn't have made the transition, and C++ was that bridge. And I look at a lot of languages as bridge languages. So I consider Scala, Groovy, even languages like Kotlin as bridge languages. So to me, the new bridge languages are things like JRuby and Scala and Groovy and Clojure and Kotlin, and they are connecting this group of developers from one paradigm onto another. And of course, as the Java ecosystem evolves, as the Java language evolves, it becomes a lot easier for some of us to go back and forth between languages and benefit. But nevertheless, I have the deepest respect for these languages because they made it possible for a lot of programmers to make that paradigm shift across those bridges. So they all share a common trait. And what is the common trait of these bridge languages? They are concise, they are very highly expressive, and they offer functional style. But I'm focusing more on these bridge languages that I mentioned on the previous page. So they're all going to have those common traits, if you will. And of course, some of the things they promote are immutability and pure functions, having no side effect and having higher order functions. These are common traits we see in all these languages. They promote immutability, but of course they don't enforce it, and it's for us to really focus on that. They make it possible to write pure functions with no side effects, and of course we are able to make use of these higher order functions to build these applications. So when it comes to the functional paradigm itself, going back to what I talked about earlier, it started out a long time ago, a good 50, 60 years ago. That was the paradigm of programming. Now it is again gaining popularity. Well, in a traditional application in the object-oriented programming world, we perform state mutation. It's funny, the word object-oriented programming was coined by the concept of object-oriented programming was coined by two Norwegians, Dahl and Nygaard. But the name object-oriented programming was given by Alan Kay, an American computer scientist. But Alan Kay once said, when I called it object-oriented programming, I was not thinking of C++. He said, well, this OOP, of course, was never intended to be state mutation. But languages like C++ and to some extent Java promoted that model of state mutation, and we kind of got misguided in the wrong direction. But the goal is not to mutate the state. In the functional programming world, we think of state transformation rather than state mutation. So often we deal with immutability, and so we take the data and we transform the data using these pure functions to get a new set of data, which then we pass to pure functions in order to get a new set of data, and then we go through this transformation. This is a very powerful pattern of a functional composition, and we use that not only in this case in functional programming. This also forms as a basis for reactive programming as well. So a very powerful concept, if you will, that we can benefit from quite a bit. So a lot of these languages, the bridge languages, are really game changers. Like I said, I have the deepest respect for these languages because they have left a mark on not only a vast group of programmers, maybe a generation of programmers as well, who come in and start thinking differently and influence the world to think differently as well. So what can we do to make these changes and benefit from those? I'm going to talk about what we can do as a company, and I want to talk about what we can do as a person, as an individual as well. Let's focus on both of those things. What can I do as a company? Well, if you're part of a company where you play a role in architecture, you play a role in enterprise decision making, I encourage you to have some corporate strategy. Evaluate the risk of adopting different technologies, but also look at the reward as well. You want to think about the risk for sure, but you also want to really think about the reward as well. One of the biggest problems really is when we think about the reward, but about the risk, but we fail to really think about the reward. I really want to emphasize this. Recently, I tweeted about it. I'll pull up the tweet here in just about a minute. But one of the things I tweeted about was that exact concern. We are worried oftentimes about, what is it going to cost us to do something? We are worried about, oh my gosh, if I do this, it's going to be expensive. It's going to take time. It's going to be a learning curve, and so on we talk about. But I want to really emphasize, we always think about the cost of doing something, but we need to go a lot beyond that in general. I think we need to really focus on that as well. So for that, I would say one thing here is don't evaluate the short-term cost of something without also considering the long-term cost of its absence. So when we talk about what is it going to cost us to do something, I want to also ask the question, what does it cost us for not doing it in the long term? So you're absolutely correct. There is a risk involved. There is a pain we have to go through in the short term. But the missed opportunity in the long term and the benefits we can gain from it is something we often tend to really ignore, and we need to really focus on that for us to be able to gain, and that is something we need to really do pay attention to in the long run. That becomes absolutely critical. So ask the question, what are the risks, but also consider and evaluate what are the rewards as well, and make that as part of your corporate strategy to evaluate those things. And talking about it, we can learn from the history quite a bit. This is not very far from where I live. I live near, Boulder, Colorado, somewhere near Denver. And it's got some real good history in this area. Well, way back in the 1940s and time, when there was a need for transporting mail from Salt Lake City, Utah, all the way to Cheyenne, Wyoming. Well, this region is absolutely beautiful. One of the reasons I decided to stay here, but it also contains a lot of mountains. And as you can see, as the crow may fly 370 miles from Salt Lake City to Cheyenne, you can't quite do that because there are some very, very deep mountains up here, or high mountains up here, and you cannot really drive through those, obviously. So what they would do is for trucks to really start driving around these mountains through the passes, and that was a lot of treacherous path. In the winter, it was incredibly difficult to drive as well. Mails would be delayed, mails would be lost, and so on. So this was a pain they were dealing with. And of course, as they were dealing with this pain of these trucks going back and forth and delivering mail, there were a few pioneers at the time, but notably one of those people was the gentleman, L. Ray Jepson. And Jepson was remarkable because what Jepson did is he decided to fly an airplane from between this route, and he would make trips every day. But as he was making these trips, there was a problem. One of the biggest challenges was that the weather was really, really bad, and suddenly things could cloud up and airplanes would crash on these mountains, which is going to be really a disaster. So what Jepson did was, as he flew this route, he started creating a flight map of the region. And it turns out he would draw these maps, and other pilots would pay him to purchase this map. So he became one of the first pioneers to devise these routes and sell these maps to other people and make money out of it. Well, you probably know what that airline was. We recognize that airline much more today, and that airline eventually became what's called United Airlines. So if you fly United Airlines, know that there is actually quite a bit of history behind it. And United Airlines in the original days was really flying mails across routes back in time. And that was a pioneering activity. Now think about that for a minute, right? Look at how challenging it is to go into a mountain area where nobody has done before, where they're driving trucks through these mountain passes, and somebody comes along and says, I'm going to fly airplanes across. Now, that seems really trivial to us today with the modern technology we live in, but those were pioneers who were doing this for the very first time. They definitely took the risk. Well, look at the reward we are today with all those benefits we have seen, and remarkable. And in fact, the Denver airport actually is named after Jepson. If you ever visit Denver, make sure to stop by the main terminal and see his statue over there and the history behind it. And that's an example of what we can do if we were to really consider not just the risk, but also the long-term reward, and then cautiously provide these services and make innovations, if you will. It also turns out that the world is really made up of these kinds of innovations. So as they say, failure is a stepping stone for success. So one of the things we really want to do is to fail fast. Well, this is something we can learn from the bees. So it turns out the bees actually create what's called the forages, where the bees go out in groups looking for, where there is honey. And all these bees go away looking in groups, and a lot of groups of bees won't find anything, but some groups will find honey, and the minute they do, they come back and they play a special dance, and other bees notice this dance and know that there is victory. One group has found honey, and all the other bees will follow them. Well, it's a great way for us to innovate on technology as a company. So as a strategist in your company, as an architect in your company, as an enterprise planner in your company, how about doing that? Come up with small teams and give the opportunity for these teams to explore frameworks, explore technologies, explore solution. And yes, 3 or 4 or 5 different teams may go try things, and most of them may not succeed, but when they do, they could have this, dance, if you will, and notify the rest of them they have a better solution, and the rest of the teams can then adopt to it. It increases the chances of your success. Rather than trying to put all your eggs in one basket, so to say, you are able to provide this opportunity for smaller teams to explore ideas and then adapt what actually works based on which team succeeds in the solution versus other opportunities. The teams really put the effort but could not find a solution that was really good. That improves the chance of the success for a company in terms of adopting technology, because you're making a prudent decision based on real prototyping and experimentation rather than hypothetical discussions, if you will. Well, we talked about what you can do as a company. What can you do as one person, as an individual? I think there's a lot we can do as a single person if we really put our mind into it and believe that this is better for the company and better for us as well. As Alvin Toffler said, the illiterate of the 21st century will not be those who cannot read and write, but those who cannot learn, unlearn, and relearn. What a beautiful way of thinking. The illiterate are not the ones who cannot read or write, but the illiterate are the ones who cannot learn, but more important, cannot unlearn and come back to relearn as well, as that becomes extremely critical. So we definitely don't want to be those illiterates. Well, in a way, we can structure our environment in our companies for us to be a lot more effective, if you will. So one way to do that really is to learn from some research. For example, I'm a big fan of the things like the Pavlov's experiment, and it's about classical conditioning. He found out that the dogs begin to salivate not when they see the food, but when they see the person who is going to serve the food. Now think of that for a minute, right? So, and I'm sure we all kind of say that as well, or see that as well in our own self. So the problem really here is, excuse me, to think about the environment, and environmental stimuli results in a behavioral response. So what if we can create an environment where the environment is conducive for people to explore. Environment is conducive for people to innovate. We can work towards creating an environment where within our own groups, among our own peers, we encourage and challenge each other to push the boundaries, to come up with innovative ideas. Not that we will implement everything that is found, but we will encourage people to explore, to prototype, to critique, to comment, and to evolve. Then the environment really changes where we thrive on innovation, we thrive on exploring rather than holding steady with technology that's of the past. When I go to companies and I ask them, what Java version do you use? And when people say they still use Java 7 or they still use Java 8, why are we stagnating? And that's one of the things we want to really ask the question, what can we do to remove such stagnation? And one of them is to create an environment which provides this opportunity, the stimuli to innovate, to research, to explore, to have the courage to say, we will explore things, but we are not condemned to use everything we find and explore, but we will learn continuously and bring what makes actually good sense so we can create an environment to do that. And of course, environment shapes our behavior. That's one of the reasons why environments are extremely important. If you ask me, what do I really look for in a job? The first thing I ask people is, who are the people? How do they learn? How do they challenge each other? How do they take criticism? I want to know those things when I go to a company. If it is not a good environment, why do I want to work over there? Because environment shapes behavior. If you want a better outcome, you need a better environment. And we are part of that environment to be able to shape it. So we don't want people who are going to hide in a corner and work alone. We want people to collaborate with each other. I would rather have a team that comes together and works with each other rather than put people in isolation and say, separate out. And I thrive on pair programming. I thrive on interaction because I am eager to learn from other people what they know, as much as also share a little bit of what I know as well. And that is something very important, is to have that open mind, be inviting, invite other people to come and share their knowledge, and also invite other people to, provide what you know as well, so you can help them. So one of the things I think we can really do is actually two things I think we can really do. First is we want to learn new languages. So take a language you are very unfamiliar with and spend some time learning that language. It's got to be different from what you know so that it changes your thinking, changes your thought process, but also embrace the newer versions of the languages that you use. So in the company, ask them the question, hey, we're using Java, but we are stuck in that version of Java. Give me a path when we are going to use a newer version of Java, because the language is moving forward. There are better solutions in the language. We don't want to be left out. We want to start using those things. So we want to be part of defining that path as well, so we can decide on when the transition is going to be. And I think we can contribute to that as individuals by asking these questions and motivating the rest of the team to move in that direction. As JFK said, there are risk and cost to a program of action, but they are far less than the long-range risk and the cost of comfortable inaction. And I remind myself of this a lot of times. Doing things is hard, not doing things is easy, but it's more expensive in the long run not doing things. That inaction is more expensive than action, and we need to be really careful about it. And I think we as developers can greatly influence change in organizations and be able to benefit from all these changes, not just in frameworks and libraries, but in languages as well, by embracing new languages, but also embracing newer versions of the languages we already use. I think we can definitely do that. So let's go rock the world and make it a better place. I hope that was useful. I want to thank you for taking the time to join. And I hope you all found this useful. Enjoy your rest of the day. Be safe, and I really, really hope to be able to see you all in person, hopefully next year. Please do stay safe. I'll be delighted to take some questions, hear your thoughts, hear your concerns. Anything you want to talk about, please post them on the chat or unmute and speak on the microphone, whichever is convenient for you. So I'm going to invite Hilmer back to engage in a Q&A and discussions. And that's all I have. Thank you so much. I really appreciate it.
Thanks, Benka. We are here. And can you start sharing the screen, please? Okay. Okay, let's check. Diego, do we have some question in YouTube?
Yes, actually, yes, we have a question from our YouTube channel. Ariga Capella is asking us, can Kotlin replace Java? What do you think?
Honestly, I don't think it will. I don't think it will. Let me give a broader answer to that question. I don't think Kotlin will replace Java. I think something else is going to replace Java. It has to, right? Because if you really look back in history, languages were popular for 10 years. Can you think of any language that's been popular for more than 10 years? I can name 2 so far. But if you look at C++, popular for 10 years. Fortran, popular for 10 years. So the life of a language is longer, but the life of popular time is about 10 years. The 2 languages that has defied that logic, both start with a J, both start with Java, of course. One is Java, the other is JavaScript. And Java and JavaScript are the only languages that's been popular for more than 10 years, going strong into 25, 26 years. Java and JavaScript were created at the same time. I'm going to say that Kotlin is not going to replace Java. The reason I say that is the problem we are facing today is not Java. The problem we are facing today is the platform. And the platform is going to fundamentally change in the next 5 to 10 years. We have been clinging on to stuff that we've been doing for about 20 years, and there's only so much the platform can hold for that long. Think back in time, we were programming mainframe computers. Then we did mini computers. Then we did, desktop. Then we did web. Then we did mobile applications. But now there's the tension between mobile and web, but there's also IoT solutions. The question we want to ask is the environment like the JVM sufficient for all platforms in the future? And I would say the answer is most likely not. And that's not an imminent problem. That's not a problem in the next 1 or 2 years. I am thinking 5 to 10 years from now. So the 5 to 10 years from now, the problem is not between Kotlin and Java. I think the problem is a lot bigger. And so there's going to be a shakeup in the industry in terms of technologies. And I can't tell you whether that's a JavaScript that's going to influence it, Python that's going to influence it, or maybe WebAssembly that's going to influence it even more, where the WebAssembly becomes a platform of development. And when WebAssembly becomes a platform of development, we're not talking about Java and Kotlin anymore. We're talking about any language you can program for the WebAssembly. So maybe it becomes a level playing field at that point, and we become truly polyglot. So I know that was a long answer, but I don't think the problem is as narrow as Kotlin overtaking Java. I think the problem is a lot bigger in the long run.
Okay, no more questions from my side.
So which could be the language mastering IA? I don't know if there is a language that you should really master, in all honesty. The reason I say that is, one of the strengths, in my opinion, is the diversity of language paradigms. So to me, so let me put it this way. There was a time when I knew one language really well. And looking back in time, I would say that's the worst of my time as a programmer, where I knew one thing really well and nothing else. So what is really important is the diversification of the language portfolio. If we learn, pick a language in different paradigm, if you will. And when you pick a language in different paradigms, it influences a different thought process. And then when you come back to design your applications, you bring that wealth of knowledge into your design. And to a great extent, I would even say, I'm one of those people who vehemently say you shouldn't really become really good in one language. The more you become good in one language, the less you actually get in the long run. So you really want to be fairly good in multiple languages, but not exceptional in any one, in my opinion, because there's a cost of doing it and there's a consequence of doing it as well. I would recommend not doing it.
I have a question from my side, Benka. Can you tell us 3 languages to learn? I don't say before that, 3 language that you recommend younger to learn.
I would again not recommend a language, but I will recommend paradigms. And I really emphasize that because to me, using multiple languages explores our mind. So rather than a language, focus on a paradigm. So for example, for myself, I'll talk about my own journey. I used to program in C++ predominantly. And sure, I want to learn object-oriented programming. So I learned C++, I learned Java, I learned C#. But then I realized that I don't know anything about dynamically typed languages. Sure, I have touched JavaScript and came running screaming, right? But I really said to myself, I really want to learn dynamic type languages. So I looked for dynamically typed languages, and I learned Ruby, I learned Python, I learned JavaScript, because I really want to learn dynamic typing. Then I wanted to really learn about functional programming and message passing. So I actually spent time learning Erlang and Haskell for that reason. And both Erlang and Haskell really opened my mind in terms of functional programming. Then when I came back to the JVM, the Ruby and the JavaScript knowledge helped me to write code in Groovy. The Erlang knowledge, honestly, helped me to write code in Scala. Erlang is a dynamically typed language. Scala is statically typed. But Erlang's messaging is similar to Scala's messaging. So as a result, the way you create processes and communicate between them, that was an easy transition for me because those languages helped me to do the paradigm shift. When I learned Haskell, for example, the functional nature of Haskell really made me rethink about a few things. Then when I learned Elm is a language where the syntax is almost 99% Haskell, but it translates to JavaScript. Elm blew my mind. When I went back to programming JavaScript, I write JavaScript differently today, thanks to the influence of Elm. And that is the benefit I see. So I think it would be a disservice for me to say, pick these 3 languages, because I'm not focused on the syntax of the languages. I'm really focused on the paradigms. So pick one from dynamic type languages, pick one from functional language, pick one from object-oriented, pick one from scripting, and start learning different languages in each of these paradigms. That makes, I think, us a more complete programmer in the long run, rather than being an isolated programmer. This is one of the reasons, with all respect, I often say, I will never call myself a Java programmer or a C# programmer or a Python programmer, because it's like somebody knocks on the door and he says, I'm a hammer plumber, right? I'm a screwdriver plumber. No, those are tools. Our job is to be a problem solver. So I should have a fairly good comprehensive idea of what these technologies are. And that's also really important for those who aspire to become a lead developer or an architect, is that you don't want to specialize so narrowly that you cannot really think about the problems these things solve. So I would say focus on the paradigm, use the languages as a vehicle to learn the paradigm, and be willing to switch between them. It's incredibly hard in the beginning, but the more we do, the easier it becomes over time.
You have some question in YouTube. Can you read it, please?
Okay, sure. So 2 days ago or so, GitHub delivered this new feature, GitHub Copilot. What do you think about it? Would become a sort of a developer assistant? I don't know. I really don't know. I don't focus so much on the tools myself. My area of focus is very different. So honest answer is I don't know. I don't spend too much time on the tooling in general. Sorry, I couldn't help you with the answer.
Hi, Vicat.
Hey.
Hey, I'm Chris Engelman's friend. I have a question. This is more related to new developers. Do you think the new changes in Java or evolution in Java is helping out to these new developers set up the current version of Java? And what do you recommend to learn for these new developers? Java 8 or now go to Java 11 or Java 15?
A good question, and I would first of all, before I answer that, I want to define the word new developer. So there are two kinds of new developers, right? One kind of new developer are developers who are new to programming. The other new developer are people who are used to programming in other languages or previous versions of Java, may have gone to program in other languages and come back to program in Java. Well, one of the things I've really found out is, let me give you two examples that just absolutely blew my mind. I have one of my children wanted to program a little application, and this was using JavaScript, came with no programming experience. And I told him, I'm going to teach you how to do unit testing. I'm going to show you how to write some code. And when we are done with it, I'm done. You're on your own. I will not help you with your program. Figure it out. And all I did was did a few sessions on unit testing, showed how to write some code with tests, and I walked away. And he was able to go on and write the program after that with that basis. Another one of my children has never done any programming at all, but wanted to develop a prosthetic hand using C++ and servo motors. And all I did was simply show how to compile a C++ code on the machine and walked away. And he was able to figure it out. So the point I'm getting to is people who don't know much have no baggage at all. It's people like me who have the most difficulty, right? Because I've got so much I know, and all that is weighing on me and saying, don't change. You want to hold on to what you know. So the new people are the ones I love the most, because you throw something, they just grab it, right? And then they are able to deal with it really quickly. And I work with quite a bit with new, let me say young programmers and written new programmers quite often. And companies hire me and say, go, coach these people and train them. And I find that to be the most rewarding because they are very curious. They also come back and challenge and say, but I can do this in Python. I can do this in JavaScript. How do I do it here? So they're eager to take these things. On the other hand, with the newer features in Java, seasoned Java programmers have the most difficulty. The reason is they're like, oh my gosh, I've done it this way. Why am I changing it now? It's really hard for us, the seasoned programmers, to see the light of the changes. The young programmers don't have a problem at all. So where would I start the new programmers who are coming in? I would start them with the latest version. I would start them with showing how to write both imperative style code and the functional style code. Let me emphasize that. One of the things that I fear the most is trying to tell anyone that there is one right way to do. That, I think, is the most fundamental flaw if we were to do it. I also teach part-time at the University of Houston. And over the years, I'm very thankful for the opportunity they're given. But I went to them maybe about 10 or more than that, about 15 years ago. And I told them, hey, I want to teach a course on programming languages. And they said, go teach whatever you want to teach. And I was so happy. And what I really wanted to teach the students at the university was that there is no one way to do things. So I'm actually teaching a course right now where I introduce, I'm not exaggerating this, I introduce 20 programming languages in one semester. Students actually pick and use anywhere from 5 to 8 languages within 3 months. And I can tell you how quick they are in picking these up. They write automated tests and they solve problems using languages they never heard about in the past. And when they're done with the course, they come back and say, oh my gosh, I used to program in one language and I thought that's the only way to do now. Now I know there is no one way to do things at all. And all I want to do is seed that doubt in their mind to say, hey, there are many ways to do it. This is one way to do, and I'm going to explore and see and compare and contrast and pick the one that is better for a given problem. And I think that it's important to really expose them to different ideas, expose them to different solutions, because it would be a disservice to really hold them back to what we are comfortable with, because they need to go explore a lot more than we may otherwise want to do ourselves. And that is something we need to really honor for the next generation of programmers.
Thanks, okay.
Thank you.
Okay, we have another question from our YouTube channel. And the question is, will functional programming replace object-oriented programming?
It's really good question. And this is one of the things that really puzzles me, because a lot of us want to throw the fight between functional and object-oriented, but I don't see that at all happening. And the reason is there is really a good synergy between functional and object-oriented. Let's step back for a minute, right? So if I were to write program without objects, I can write functions. But when I write code with objects, what do I typically do? I write code using imperative style to work with multiple objects. And within an object in an instance method, I'm writing imperative style code. So we never program in object-oriented. We program in object-oriented plus imperative. So my question is, if you're programming with object-oriented plus imperative, why not program with object-oriented plus functional? So my hope is not again a replacement, right? I don't believe in replacement. I believe in coexistence. I think what we're going to do eventually is we're going to do OOP, but we're going to mix it with functional style where it makes sense and mix it with imperative where that makes better sense. So I don't think one is going to replace the other, but it's going to be a coexistence of these three things that are going to play together. We're going to still program OOP. We're going to mix functional style with it, and we're going to mix imperative. So it is OOP with functional or OOP with imperative, and we're going to keep going back and forth between them. We could be doing functional at the multiple object level. We could be doing imperative inside an object, or we could be doing functional within an object and maybe doing imperative on the outside, or a combination thereof. And I think that's what's going to happen. If you look at most languages today, they're not a purely object-oriented language. They're not purely a functional programming language. Languages have become hybrid with a really good intention. And I think we're going to be doing hybrid programming quite extensively. And I think it's important for anytime somebody says, functional is the better way, I'll be there to fight. I am not going to accept it. Don't get me wrong. I love functional programming, but I'm not going to say for that reason that functional is the only way to do it. There are times when imperative is a better choice, and we should be able to embrace that as well. So I think it's going to be a combination, not a replacement at all. And definitely not OOP versus something else. It's really functional and imperative that's really competing with each other, not against OOP in general. One question I see here is from Juan. What do you think about developing with Spring as a framework to apply good practice and new paradigm? Which one do you prefer and feel comfortable to work with? Actually, I don't actually have any preference or where I feel comfortable with. That's one of my major themes, is not to get comfortable with anything. I'm a person who is uncomfortable every single day. You know, here I'm standing. This is what I do. I stand for about 12 hours a day. which is very uncomfortable, right? Sitting is comfortable. I don't do that. That's kind of what I do. Is Spring a great framework to develop? Absolutely. But I'm also looking at other things as well. I use Spring, but I also use Micronaut, for example, and I love them all. And I want to really choose what is better for a project, better for a client, better for an application. So I would say if you are comfortable with Spring, that's great. But also take the time to learn Micronaut, take the time to learn Quarkus. It's important to diversify those. The worst situation to be in is to learn one and say, that's all I'm going to learn. It's important to diversify. I am teaching courses on Spring right now for clients. I work with Spring for my clients. I certainly do that. But that doesn't mean I am comfortable with Spring only. I also enjoy Micronaut. I use that as well. Likewise, Quarkus, I'm willing to pick and play with framework. I want to diversify those, and I hope you will be able to do that as well. Is Spring a good environment to program in? Absolutely, it is. But so are other technologies as well, and we should be willing to embrace them also.
Thank you.
I think we don't have more questions, but we have some comments on the chat, and I like to let you know. So something that people are saying that, and you are very, very good.
Thank you.
The comment, and let me go a lot of hi, and welcome, Venkat, and you are great, and your energy is amazing. I'm trying to translate from Spanish too.
I'm very thankful. I'm humble. Thank you.
You are amazing. People are enjoying your presentation. Your capacity is amazing. And the way you explain is easy to understand.
Thank you.
Sorry, can I ask a question?
Yes, please.
Go ahead, Juan Pablo, please. Go ahead.
Hi, Venkat. I really appreciate and enjoy your talks. And you mentioned the paradigms, the imperative and the functional style. I'm wondering if there are some special use cases where the imperative style makes more sense in contrast with the functional, or if you can give us some example.
Oh, absolutely. Really good question. Definitely the answer is a yes. In fact, before I give you that answer, I'll even emphasize this. There's a really good reason why Project Loom is being developed, because Project Loom is really going to bring imperative style programming to the forefront. And there's a reason for that. The good news about functional programming is functional programming has less complexity. It's easier to parallelize, easier to reason with the code. So no doubt about it, I love functional programming. But the reality of the world we live in is there are times when our code will have side effects. There are times when our code will have to deal with exceptions in the code. It turns out that functional programming and exception handling are mutually exclusive. You don't do exceptions with functional style code, period. You know, when programmers come to me and say, hey, in Java, we cannot deal with exceptions in the Stream API, so we're going to find a way to do it, I cry literally. Because the reason they didn't do it is not because they don't know how to do it. It's because it shouldn't be done. So the functional programming API is not going to work with exceptions. If your code fundamentally contains IO, if your code fundamentally contains exception, if your code fundamentally contains impure operations, it's fool's errand to try to really make it functional. At some point, we have to realize this code is better in imperative style, and we should really write it in imperative style. You know, I was teaching a course a couple of days ago for a bank, and a developer came to me and said, hey, I have this code I've written in functional style. Tell me what you think about it. I said, it's really a bad code, not because you wrote it, it's because you forgot about one thing. You're performing a shared mutability in your functional code. You shouldn't do that. That's a really bad practice, because if you parallelize the code, everything is going to go wrong. And we parallelized it and things went wrong. And then he said, how would you write this code? I said, you know what, with all honesty, I would write that code in imperative style. I will not write that code in functional style because it doesn't benefit from the functional style. By nature, it's an impure code. I wouldn't use functional style for it. So that's what I would evaluate, right? If a code has to deal with impurity, if a code has to deal with exceptions, you know, it's not a shame to write imperative code. I want to really emphasize it, right? We're not in a competition. We don't need to shame programmers say, oh my gosh, you're writing imperative style code. If somebody knows both the paradigms and they willfully choose to program in one, I have the deepest respect for them because they made a wise choice. If somebody doesn't know a paradigm and they're using a biased decision, that's not a good thing. So when somebody makes an informed decision, that's a good thing. And there are times when imperative is better than functional, and we should definitely respect that.
Okay, thank you, Venkat.
Thank you.
Okay, si no tenemos más preguntas, creo que podemos ir cerrando. Quería primero hacerles una invitación a que nos sigan por nuestras redes sociales en Twitter. Por allí constantemente estamos colocando información sobre charlas. Por ejemplo, ya se acerca el tiempo para la Jakarta UAM. También hacemos charlas una vez al mes con las demás Java User Group de la TAM. Están invitados a que nos sigan para que se den cuenta qué días vamos a estar charlando. Quiero agradecerle a nuestros patrocinadores, a Ceiba y a S4M por estar patrocinándonos en el evento, a la comunidad en Java en Medellín, en Bogotá y en Cali y en sus alrededores. Muchas gracias a Venkat. Dr. Venkat, I want to say thank you very much to be attending these jConf talks. We appreciate it. You're welcome whenever you wish, whenever you want.
Thank you. Stay safe, and I definitely look forward to being there when travel becomes possible. I definitely miss being there. I thoroughly enjoyed the last time I was there, and I can't wait for the next opportunity to visit again. So thank you so much.
Thank you, Venkat. Thank you, everybody, to join this conference online. I hope in the early future, or in the or soon we can have on person talk, meeting, conference, or whatever. We can meet Venka and all people that attend this conference. Okay, thank you, guys. Thank you, Venka, and I hope I see you.
Thank you, Venka.
Thank you.